Hi everyone, my name is Agbo Dozie and I'm a co-founder at 17Quantum where we are building Africa's biggest quantum revolution.
Hello guys, my name is Russell Gali and I'm one of the co-founders at 17Quantum.
All right, so Africa has been infamously known for taking a backseat on the biggest development in the world. So from AI to satellite technologies and space technologies. With 17 Quantum, my team and I particularly want to change that narrative. We believe 17 Quantum is the next big thing that is going to happen to the world and definitely to Africa. And we want to ensure that Africa is on the map as the revolution unfolds. The name 17 Quantum, interestingly, was coined from our understanding of the standard model of particle physics, where we have 17 fundamental particles that make the building block of our universe as we know it. And we, combining our inspiration and the mission that we have to drive the revolutions of Africa's quantum future, believe we can only do that by starting from the fundamental into the technology. And that was why we chose the name 17 Quantum.
So at 17Quantum, I think one of the most important things we're trying to do is to make quantum computing accessible to everyone by taking it online. So it means that what 17Quantum have currently is an educational platform that anyone around Africa can access online and anyone across the world beyond Africa can also access online. So by making quantum computing accessible online, it gives everyone an opportunity to be able to access the course and programs we have installed for you. Now, I think another important point to also note is the curriculum we're trying to build. So our curriculum does not just satisfy those who are fast learners, it also satisfies those who are slow learners. From taking the very core of what we understand in current computer age, from third generation computers to second generation computers, to as far as understanding the need for quantum computers. So it means that for someone as low as a middle school, or what I would call a secondary school, even down as low as primary school student, can actually learn quantum computer from zero to quantum. But I think with this, we're really trying to do something really meaningful with zero to quantum, making quantum computing accessible to everyone.
Great. So Africa has three big areas where we need to upgrade. One is agriculture, one is energy, and one is medicine. A lot of people die as a result of malaria in Africa. A lot of people do not have access to energy, which is a big problem. And a lot of people struggle for food, and climate change is a big disaster in different parts of Africa. We believe accelerated computing can help us address some of these issues because quantum computing is great at optimization problems and building simulation models. So we strongly believe that deploying quantum computers in Africa, in the area of agriculture, in the area of energy, in the area of medicine, precision medicine specifically, will be able to tackle these problems, and Africa would be at the forefront of solving the problems that are unique to the continent.
Okay, the next question is, what are the practical applications of quantum computing for Africans?
All right. So I think the better way to simplify quantum computing for you guys would be that imagine where in a world where you can actually do everything you want to do in a particular day all at the same time. From waking up in the morning to brush your hair, from waking up in the morning to wash your teeth, brush your hair, going to the office, getting your job done in the office, going to the grocery store, getting yourself something to eat for the evening, even coming back home to watch Netflix. A quantum computer can afford you to do all of these things all at the same time. Unlike what a classical computer can help you do. It can only allow you to do each of these things one after the other. And what makes this impossible for quantum computers is what we call the quantum bit, or in short, qubit. So qubits work on the principles of quantum physics, which means that a system can exist in a state at the same time. For example, if we have a one state and a zero state, a quantum computer can allow you to exist both in a one state and a zero state all at the same time, unlike a classical computer. A classical computer can only allow you to exist in a one state or a zero state, which means that you can either have a system that can actually be on or off for a classical computer, but for a quantum computer, you can have a system that is off and on at the same time. Don't you think that's crazy enough?
One application is in the area of medicine. Africa has very, very peculiar diseases and illnesses that you don't find in other parts of the world. And so the West is not incentivized to solve these problems. The challenge with solving this problem is that it takes a lot of research funding, a lot of effort, and a lot of experiments. With quantum computers and the principle of superposition, you can try multiple experiments simultaneously, and you do not need as much research funding as you would. So I believe Africa can harness the power of quantum computer for the purpose of drug discovery. Also, Africa makes the largest amount of online transactions in terms of banking um, in the world compared to any other continent. What that means is that it will be very important to ensure that encryptions for these financial transactions are safe. Today, that encryption is being threatened. Quantum computers can offer quantum safe algorithms that will protect your bank from being hacked by a classical computer user in future. Also, very importantly, is energy optimization. Africans have low access to energy. You can count a handful of homes that have access to energy out of 10 in Africa. What that means is we need to do more, not just from a policy and government point of view, but from technological point of view to solve this problem. We believe that grid distribution and energy optimization, which is a Herculean task for the current computing infrastructure that we have, can be addressed with a more robust machinery like a quantum computer. And these are some of the areas we believe we can apply quantum computing, not to mention so many other areas that you will come to learn about as you join our community. Thank you so much.